Hello everyone, this is Huanlin Zhang speaking. Today, I'm happy to introduce you one of the advanced modeling solutions provided by ProPlus. SDEP is short for Spec-Driven Extraction Platform. SDEP is a fully automatic model extraction tool that you can build your own flows or easily adopt our customized reference flows for the modeling needs such as best fitting, retargeting, and corner. SDEP now supports BSIM 4, BSIM bulk, and BSIM CNG models. In the following slide, I will use about 5 minutes to show how SDEP can benefit your business, and in another 5 minutes, I will do a short demo of SDEP using BPP. SDEP has a key differentiator among its competitors in its spec-driven feature. Specs can mean fitting criterions or QA rules. SDEP optimization is not just fitting only, but meeting multiple rules at the same time. It can achieve an optimal balance between the specs, IV-CV curves, and the KOP trends. SDEP can give you a faster model time to market, from weeks to only hours. By the end of 2020, we are targeting to reduce it further down to minutes. Here, we show you a very challenging 28 nanometer BSIM 4 project with a lot of device sizes and a large array of KOP and corner targets. We use a bin model approach to ensure the highest level of accuracy while providing an on-the-fly QA inside SDEP flow to guarantee the model quality. In this particular case, traditional manual tuning needs at least 3 weeks to finish. With SDEP, it's down to only 5 hours to complete best fitting, retargeting, and corner. That's at least 20 times faster than the current practice. Powered by SDEP, model extraction is not a burden for engineers anymore. SDEP engineers prepare the initial model with basic process parameters and model modes they select only. Then they check the data quality and check whether the specs are reasonable or not. During the flow, there is no human intervention at all. Finally, engineers review the models, doing comprehensive QA, and sign off the model quality. They could adjust the modeling strategy, such as global versus bin, in the flow if they wish. When there is a new process change or different application focus, SDEP engineers adjust the input and run the flow again. By deploying multiple machines running SDEP simultaneously, you can ramp up model throughput of your team without the impact of engineer turnover. Or you can deliver application-based models by adjusting different specs at the input. For example, you can get a digital model focusing on I-on, I-off, and an analog model focusing on GM-GDS, even using the same set of data. Above are my prepared slides for the SDEP presentation. If you have more questions, you are welcome to email me or our marketing representatives. Thank you. Hello everyone, I'm going to show you the SDEP environment inside BPP. Here you can see on the left-hand side, it's the sequence tree we have. And here we are going to demo you a best fit flow. Here you can see a lot of groups. Each group define an action in your modeling extraction. Inside the group, you have many steps. And in each step, you have many properties that you can set. And you can also add whatever steps you want to build your own flow. Here we will show this best fit flow for you. In the interest of time, I'll only show you 3 groups. The first one is an optimization for a single long channel device. And then I will show you a CV and IV co-optimization group. And finally, I will show you a group similar to this long channel, but it's a short channel device. And at the end of each group, I will pause there to give you a time to see the plots. Okay, so let's run the preparation group first. You can auto run it, and you will run it very fast. Since it's a preparation group, so I will not spend time on it. Okay, it's down. So now let's start from the long channel device. So let's auto run it. So here it starts to optimize the substructural region. And this is the GN curve with the substructural region. Then it starts to do the body effect in substructural region and in the strong inversion region. This is the overall mobility part. And in this step, we will do structural voltage trend across different W and different Ls. And here you can see the maximum function cost is 500. So at the bottom of the BPP, there's a countdown iterations here. It will stop when you hit the 500s. And during the optimization, the error will go down and down until it converges. Okay, so now you see the VTGN trend here. And the final step is you put in all IV curve linear and saturation together. So here you can check all the plots, ID, VG curve here, GN curve here, ID, VD at the different VB, and RR curve. Here is just the initial start for the largest device, and we will do the refine later. Okay, let's see a CV step here. So it's very fast. We did the CGG curve and CGC curve together. And the next step is CV-IV co-optimization step for the largest device. So here you see the CV curve and the IV curve optimize it together, and it's very fast. Now let's do the shortest IV here. Let's do auto run again. So the same substructural region, GN curve together with body effect. It will do different regions step by step. And the GN curve with all the body effect. Overall mobility part. This is the saturation curve. And finally, it's doing all the IDVG, IDVD curve together. Since there are many parameters here, so it takes longer time, but it's finished now. So let's review the curve. This is IDVG, different VD, and GN curve, IDVD curve with different VB. And here is the RR curve And you can see that there's an outlier here, but Steve handles it very well, giving you a very physical trend here. Okay, because of time, I can only show you here. If you are interested in more of what STEEP can help you in your modeling business, please contact our marketing representative. Thank you.